So transformations are a pretty important tool in a molecular geneticist or molecular biologist or microbiologist toolkit. So when we do transformations, it can be helpful to be able to find a way to express how efficiently that transformation worked. And the way we do that is using a term called the transformation efficiency. And the transformation efficiency is expressed as colony-forming units per microgram of DNA. And the transformation efficiency can tell us something about how competent the cells were, in other words, how capable of taking up exogenous DNA they were, and the quality of the DNA. So let us pretend that we did a transformation reaction using one of our favorite plasmids. Our favorite plasmid could be PEDLO, it could be PUC. Both of those plasmids have a gene for ampicillin resistance on them. And let us pretend that in our transformation reaction here, we had 200 microliters of competent E. coli cells. And into those E. coli cells, we put 1 microliter of 10 nanogram per microliter DNA. In other words, there was a total of 10 nanograms of DNA put into these 200 microliters of E. coli for the transformation reaction. And let us pretend we proceeded with our transformation. And when we were done, we decided to go ahead and plate, let's say, 1/2 of our transformation reaction. So that would be 100 microliters onto an LB plate containing ampicillin for selection. And let us pretend we plated the other half, 100 microliters again, onto just a regular LB plate. And this would be an important control for viability. And we'd expect a good lawn of E. coli on this plate because there's no selection. And we would hopefully get colonies on this plate, and these colonies would represent transformants. And let us pretend that I counted those up dutifully the next day, and I noted that I got 300 colonies on this plate. So in order to calculate then the number of colony-forming units per microgram of DNA, I need to think about how much DNA gave me this 300 colonies. And the answer to that is it was 5 nanograms of DNA gave us this 300 colonies. 5 nanograms is what was present in, let's say, that 100 microliters that we put on the plate. So then, in order to figure out the transformation efficiency, I might proceed as follows. I would say I had 300 colonies corresponded to 5 nanograms of DNA, and that's going to be equal to however many colonies I would get in 1,000 nanograms of DNA. So I'm going to go ahead and solve for X here. Okay, so our transformation efficiency is going to be 6 times 10 to the 4 CFUs per microgram of DNA, because that's how many colonies we would have expected if we'd added a whole 1,000 nanograms instead of 5 nanograms.